Welcome to Brain Vision.
Let's find the equation of the tangent plane to the surface given by this equation over here and at this given point. So the equation of a tangent plane is given by the following. So we have our partial derivatives evaluated at the x and y values of the original point times x minus x naught, and then add in a similar looking term, but this time involving the partial derivative with respect to y, and then multiply by y minus y naught. So in our problem, the z is given by, that's just the variable that'll be present in the equation of our plane, just like the x and the y. And then we'll use f of xy to just be this function here on the right-hand side. So this is the function that we'll be taking the partial derivatives of. And then we can see our x naught, y naught, and z naught is the given point. So we know these numbers as well. So before we start plugging this information into the formula, let's just go ahead and find those partial derivatives. So the first one is the partial derivative at any point xy. So in this case, we look at our polynomial. X is the only variable here and for the first partial derivative. So we just differentiate that with respect to x. And then similarly, with respect to y, we would get -4 y minus 1 using the power rule. So now we can go ahead and plug in the points here. So fx, now we plug in 2, 3. And you can see this only depends on x. So just go ahead and plug in 2 into there, and that'll give us an 8. So we'll have 2 times 4. Similarly, plug in the point 2, 3 into fy. So this time you're getting -4, but now we have 3 minus 1, which is 2. So -8. And also, let's not forget that the z naught is given to be 3. So we'll go ahead and plug that in. So that z minus 3, partial derivative with respect to x, we just found that to be 8. And then x minus x naught. And then now we'll have a plus -8. So let's just write -8. And then y minus y naught. So that's y minus 3. This may be simplified, but ultimately it'll still represent the equation of a plane. So in this case, maybe we can just do an extra step or two here. And then maybe we can go ahead and get all the x, y's, and z's on one side. So I'll go ahead and subtract the 8x and add the 8y over. And then on the right-hand side, we'll have 8 and then plus 3, which is 11. So we could stop right there. And that's the equation of our tangent plane. That's the final answer.